video, I am going to discuss about the electric potential. Dear student, here I want to tell you electric potential is a scalar quantity. So it is very easy to express comparatively to electric field. And first question arises here, how can we define the electric potential? So electric potential is the ratio of work done by an external agent in carrying a positive test charge from infinity to that point to magnitude of the test charge. Suppose Q is any source charge and whole this white board is the field of electric field of this charge Q. And suppose you want to find out the electric potential at point P. Even you know this source charge Q also shows the electric field at this point as well as electric potential also at each point here. And if you want to find out the electric potential at point P, and remember that this point P lies in electric field. So for this purpose we will take a positive test charge. Suppose plus Q naught is a positive test charge and that test charge is carrying from infinity to the point P. And suppose in this case the work done is W. So by definition the electric potential at point P, which is denoted by V, is the ratio of work done in carrying a positive test charge from infinity to that point P, which is W, to the magnitude of test charge, which is Q naught. So V is equal to W upon Q naught. Remember this, here Q naught is test charge here, and that test charge I am considering what charge here? Positive test charge. At place of plus Q naught you can take Q dash also, then here you can write V is equal to W upon Q dash. So once again I would like to define what is the electric potential. So electric potential is the work done by an external agent in carrying a positive test charge from infinity to a point in electric field divided by magnitude of that test charge. The SI unit of the potential, you know, V is equal to W upon Q naught. The SI unit of work is joule and the unit of charge is coulomb. So SI unit of electric potential is joule per coulomb, and joule per coulomb is also called volt. So simply at place of joule per coulomb we can also write which is equal to what here? Volt, or this is called volt. And you can write here 1 volt is equal to 1 joule per coulomb. And how can we define the 1 volt? So simply you can say the SI unit of electric potential is volt, and volt is also equal to joule per coulomb. And how can we define the 1 volt? Suppose if at the point P electric potential is 1 volt, it means when 1 coulomb charge is carrying from infinity to the point P, if the work done is 1 joule, it means to carry a charge of 1 coulomb from infinity to the point P, if the work done is 1 joule, then you can say the electric potential at the point P is how much here? 1 volt. And in same way, how can we find the dimension of electric potential? Dimension of electric potential, we can write here this is equal to, you know, dimension of electric potential means dimension of work and dimension of charge. You know, W work and its dimension is m l square t minus 2 upon, as you know, charge q, its dimension you will write in form q is equal to it. So you will write here a into t, and finally at will transfer in numerator. Then you will get here m l square a to the power minus 1 and t to the power minus 3. You can write here m l square t to the power minus 3, a to the power minus 1, and a to the power minus 1, t to the power minus 3. And also you can write the SI unit of electric potential in an air system, or in SI system you can write here kilogram meter square per ampere per second cube. In this way you can find out the dimension of the electric potential. And here I want to tell you, dear student, you know, water always flows from higher level to lower level. Heat always flows from higher temperature to lower temperature. Similarly, the charge, a positive charge, is always flow from higher potential to lower potential. I am telling a positive charge will always move from higher potential to lower potential. So you can also write like this one here. A charge means a positive charge always moves from higher potential to lower potential, while a negative charge always moves from lower potential to higher potential. And one more thing here I want to tell you, for the potential of Earth considered as a reference body, it means the electric potential of Earth is taken 0, and it's not affected, or it's no matter what large charge is given to it or taken to it. So you can say the electric potential of Earth is considered to be 0. And in the same way we can also define the potential difference. So potential difference is the difference in potential between the 2 points. Suppose I am taking 2 points in the electric field. One point is A. Suppose this one is a source charge Q, and whole this white board is the electric field of this charge Q. It means at each point of this board, this charge Q, we also show the electric potential. Suppose I am taking 2 points A and B. It means this source charge Q is also show the potential at the different point, means also at the point A and B. Suppose the potential at point A is VA and potential at point B is VB due to this source charge Q. Then the potential difference between A and B, between these 2 points, how can we find the potential difference? So for this purpose we will take a test charge plus Q naught, and that test charge we carry from point B to point A, and suppose the work done is W. So the electric potential between AB, it means VA minus VB, is equal to ratio of work done to carry this test charge to magnitude of this test charge. This will give the electric potential between point A and B. So simply you can say, or simply you can define, the electric potential between these 2 points is the ratio of work done in bringing a test charge from one point to other point to magnitude of that test charge. This one is the electric potential. And this VA minus VB, in some book it is also given delta V, or sometime only you can say V is equal to W upon Q. So here V is considered as a electric potential, and when only one point you are taking, then at that point, at that case, second point you will consider at infinity. So if source charge is plus Q, and suppose I am taking its 2 point A and B in the field of this charge, and our aim is to find the potential difference between A and B. Then we will take a test charge, what Q0, and suppose this Q0 is bringing from B to A. Suppose work done is W and magnitude of this test charge is Q0. So this ratio of W upon Q0 will give what here? Potential difference between A and B. Remember this, if the source charge is positive, then A is at higher potential than B, and if the source charge is negative, then A is at lower potential than B. Be careful about this one. If source charge is positive, then A is at higher potential than B. Then here you will take VA minus VB. And when source charge is negative, then A is at lower potential than B. It means in this case, when a positive test charge will move, then work is done to carry or to bring this test charge from B to A. But in this case, when source charge is negative, then here work is obtained to carry a test charge from B to A. It means in this case here work is done by the electric field itself. So only one thing you remember, if source charge is positive, then the point which is closer to the source charge, at that point potential will be more, and if the source charge is negative, then the point which is closer to the source charge, at that point potential will be less. So dear student, please today you will go through this, and next video I will give you the next point or next topic of this chapter. Thank you.